And welcome everybody to the Daily Space Weather. I'm your host Dan, aka smAsho Mash. Today we'll be showing you a crown prominence, talking about a Cascadia earthquake, snow forecast, more stuff about coronal holes. We'll be doing a cosmology segment. It'll be pretty short, but perhaps informative. Let's start out looking at the sun here in a multiple wavelength view here. 335, 193, and 94 angstroms. No major solar flares. A minor coronal mass ejection has occurred. We'll get into it. 10.7 centimeter radial flux has dropped down to 87. And there's a 1-year graph of that. Welcome to Cycle 25. Welcome to the Neo Renaissance. Again, thanks for tuning in to the Daily Space Weather. The reason we monitor the radial flux is because it is proportional to sunspot number. There you can see cycle 24 in terms of sunspot number, and there is cycle 24 in terms of 10.7 centimeter radial flux progression. Also the beginning of cycle 25, which began right about here. Mid-November of last year. No, I don't care what other YouTube channels say. I probably know a lot more about the sun than those YouTube channels. Yes, like Jordan Peterson, I prefer to talk about things that I know something about. Now we're looking at the colorized magnetogram to see the slow degradation of sunspot 2795 and the steady performance of sunspot 2794. Now we've got some great helioviewer movies for you. We're going to show you some at the beginning and some at the end of the video. Starting out with this crown prominence, which happened at 12:19 Universal Time yesterday. So crown prominences are prominences at the solar poles, and we typically see a lot more of them around solar maximum as opposed to around solar minimum. So this is a good sign. This is another indication that the sun is ramping up its activity. You can also see a bunch of filaments here, such as this one. And again, we did see some coronal mass ejections happen. There's another large filamentary area over there on the southeastern limb. So a great view of that crown prominence there. It's about 2 Earths in diameter there. And let's go out to Lagrange point 5 to see the view from stereo A. So here's what was going on at stereo A, and we've got about 6 hours of data loss. As you can see, the time and date stamps there. Let me just make sure the stream is live here. And we look like we're good. Thanks for tuning in, Life Force Rejuvenation, otherwise known as Mr. Katoski. And thanks for leaving a comment. So we've got 6 hours of data loss here. And here at the Smash News Network, we don't blame conspiracy theories for that which could be attributed to malfunctions or ignorance or possibly even stupidity. But in this case, you can see there the time and date stamp 12:28 at about 8:30 p.m. And then it suddenly ends up at 12:29 around 2 a.m. So 5.5 hours of data loss or so there. And you see some vanishing plasma in that period. Although not very much. It looks like a little bit of that plasma has ejected. And we'll just let this play through here. And we'll show you where that's located after we show you this. And we're going to the SOHO spacecraft at Lagrange point 1. So this is 1 million miles closer to the sun than the Earth. In between the Earth and the sun, that's Lagrange point 1. Here's what we see from the SOHO. So the LASCO C2, you can see a little bit of ejecta there on the eastern side. It looks like there is still some coronal mass ejection unfolding now. It looks pretty minor. And again, it looks like it's oriented on the eastern limb of the sun there, not really Earth-facing. And let's show you the LASCO C3 as well. another coronagraph on the SOHO spacecraft located at Lagrange point 1. Great view of Mercury there in the lower left. And you can see a little bit of ejecta out here, as well as Comet Erasmus at the base of the arrow I just drew at the top of your screen. So Comet Erasmus, a little bit of coronal mass ejecta showing up there, not Earth-facing, as well as Mercury. Sorry if you wanted to be scared and spooked. There's nothing scary or spooky about it. Next, looking at a full disk view here in 171 angstroms, my favorite wavelength. And that active region rising there in the southeast, in the lower left, is not a sunspot, at least not yet. And again, you can see actually the degradation there of sunspot 2795, sort of right in the middle of the screen there, a little bit at southern latitude. And here's a close-up of that area. A little bit of flaring happened. Nothing to write home about. A close-up of 2794 and 2795. And we've got a 94 angstroms full disk view also. And a couple more views in 193 angstroms, so stay tuned till the end of the video. We'll do some close-ups of coronal holes and other features, both solar polar regions. First, let's talk cosmology. And before that, we'll do a little bit of Smash Lights, where I will not rant about politics. I might mention the fact that Dr. Fauci is a fraud and has admitted to his fraud. But in any case, please visit smashomash.com, visit our links there, check us out on social media, consider becoming a patron. Maybe pick up some merch if you want some astronomy-based merch. Well, there's more coming out soon. You can already get some, such as the Deneb shirt. Also, perhaps the first, some of the first merch we ever made here, the 3C405 shirt, featuring Radio Galaxy Cygnus A, the second most massive radio source in the entire sky, despite being located 500 million light years away. Cygnus A, known as 3C405. If you'd like it on a shirt, nothing says don't run me over or shoot me like a Blaze Orange shirt, so perhaps pick up that, featuring Cygnus A in radio and invisible light. And those are not to scale, it's just an overlay of the area of massive radio galaxy Cygnus A. Thanks to all of our YouTube viewers, new subscribers, etc. Please take a moment to press like and subscribe on YouTube. No, that's okay. We'll wait. As here at the Smash News Network, we're very patient. Oh my God, the place is on fire again. Sorry about that, folks. Have you pressed like and subscribe yet? The video can't continue until you do. We'll be here when you get back. You can press pause. Okay, thanks. We're also on BitChute. Sorry BitChute viewers, I haven't made any exclusive BitChute content recently. As we're reaching 300 subscribers, we'll definitely make a 300 subscriber special for that reason. And yeah, there's about masks and vaccines and lockdowns and stuff. There's some truth being told here at the Smash News Network about fraud. Let's get back into cosmology stuff. So, here's where stuff is located in the solar system. There's where things will be in a week, and if you want to have something scary and spooky to talk about, look at this. We've got a triangle forming between Venus, Mercury, and the Earth, and it's roughly Doritos-shaped. Another indication that Frito-Lay may be attempting to take over the solar system. Please leave a comment if you think the Space Force can defeat Frito-Lay. We're hoping. Also, the moon is crossing the galactic plane as we speak. Another thing to be very scared and spooked about, that blue line there, I've drawn in the galactic plane. So as the moon moves across the ecliptic, oh my God, it's almost in Taurus. Holy cripes, I'm very scared. Oh noes, Moloch is coming to eat your babies. Oh my God, it's very scary and spooky. I like to use in-the-sky for my star charts. Pardon the sarcasm. And thanks to our Twitch viewers, twitch.tv/smAsho is where we're currently streaming. They've got a great mobile application as well as a great streaming platform. We love to use it. twitch.tv/smAsho. And there ends today's Smash Lights segment. Let's start talking cosmology. As I saw a ridiculous video from Suspicious Observers yesterday, I'll get to it. First, I want to announce the fact that we'll be making a video about coronal holes. And so you can see this very lengthy screen rip that I took, which features this coronal hole that you can see here, which by the way, was on the sun for nearly 2 years. And more about that later. A cosmology segment specifically about coronal holes, possibly featuring regular guest Eugene Bagashov. So let's talk about our mission. You can read all about the rest of the mission at smashomash.com/forum/mission. It's all currently free. There's no paywall associated at all. Again, smashomash.com/forum. And the mission is at smashomash.com/forum/mission. One of the things that we like to do here is assist mankind by assisting the study of predictive and advancing the study of predictive phenomenon as opposed to nonsense in order to optimize value and reduce risk and liability and save lives and resources and adapt no matter what the adversity is, whether the adversity is ignorance, stupidity, fraud, or just people who are scamming you in order to get funded and get views on YouTube. We look to adapt no matter what the adversity is. So thanks to our patrons for helping us to adapt and keep the videos free and publicly visible. Please consider becoming a patron at patreon.com/smashomash. We are awaiting enough funding to become a nonprofit agency. At that point, we will be able to have tax-deductible deductions. But until then, consider funding us. Again, patreon.com/smashomash. And even if you're not willing to open up your moldy, cobweb-encrusted wallet and send us a few bucks per month, you may still want to consider signing up at Patreon because we do put up public posts. Now let's talk about the galaxy. So here's a view of the galaxy, and this is infrared light, and that's the galactic plane right there. And we're centered on a place called Sagittarius A star. It's the core of the Milky Way galaxy. And let's look at it in a different wavelength here. Let's look at it in Chandra, which is X-ray spectrum. So there's the galactic core region in X-ray, and you can see it emits very brightly in X-ray. Although you can't really see an object there, as Sagittarius A star is a massive radio source, and it doesn't really show up in most frequencies, we'll just say. There's a lot of gas and dust there, and there's some massive stars orbiting it, as you can see on this image. I believe that's S1 and S2, those two big blue blobs. And the point I'm making here is that the galactic current sheet, something touted by Ben Davidson as some sort of scary, spooky thing which directly affects the sun, is a non sequitur. And it's nonsensical and completely idiotic to suggest that there is a galactic current sheet which is somehow affecting the sun in the way that the heliospheric current sheet affects Earth. So the core of the galaxy is quite far away, something like 40,000 light years distant. And there is no direct effect of that on you. It is nothing like the heliospheric current sheet in any way. Allow me to demonstrate. So I've opened up Plasmascape here, and just give that a moment to load. So if you go to plasmascape.com, you'll be able to bring this up. And so going out to a galactic scale distance here, I'm zooming way out. So the sun is in this structure right here. This is known as the local chimney. And this is a chimney of gas and dust in which the sun and other local stars are located. And the galactic center is way over there, and the stars within the local chimney are moving toward Cygnus. So I've actually centered the sun right there on Cygnus. That bright spot right there, that is the Cygnus arm of the Milky Way galaxy. This local chimney is moving in that direction, toward Cygnus, Deneb. Within the local chimney, the sun is moving in this direction, toward that tab there called the solar apex. So let me just highlight that. You see that tab that says the solar apex? That is the way the sun is moving within this local chimney. Does that look like the heliospheric current sheet to you? No? What's that? No? Yeah, I know, because it's nothing at all like the heliospheric current sheet. So just to show you a close-up view here, to zoom way into the solar system. First of all, this arrow on the top of the sun, that's the solar North Pole. And you can see the North Pole of Mercury, and of Venus, and of the Earth, and of Mars in that image there. And if we zoom out a little bit, let me press A again here to see which one of those tabs is the one I'm looking for. Oh, I've got to zoom out. All right, so again, the sun within the local chimney seems to be moving toward the tab that says solar apex. So if I just rotate this a little bit, you can see solar apex. That's the direction that the sun is moving within the local chimney. And then, if you go over here to Deneb, there we go. That's the direction that the local chimney is moving. Cosmic ray flux, for example, is not coming from the galactic center. We can barely see anything going on at the galactic center. And again, the galactic current sheet, while it is a thing if you're close to the center of the galaxy, the galactic current sheet is not a thing at our portion of the Milky Way galaxy. And there ends today's Cosmology segment. I hope that helped you out a little bit with debunking nonsense, such as the nonsense that Ben Davidson regularly talks about the galactic current sheet. I wasn't actually going to really say anything about it because I wasn't sure if he was talking about this ridiculous idea that there's a galactic current sheet which is similar to the heliospheric one that directly affects the sun or not. But in the video that I watched yesterday, he certainly said it. And since he said it, I figured I would start the process of laughing and It doesn't really need to be debunked. It needs to be laughed at, as I said in his comments, and I didn't see a response. I'm wondering if my comment was deleted, although I haven't noted Ben to delete comments in the past, so I haven't gone and checked, and I frankly don't really care, because it's nonsense. The sun is not affected by any sort of galactic current sheet coming from the core of the galaxy, and I don't care what Wal Thornhill says about galactic superwaves or anything. The energy from the core of the galaxy is imparted through the spiral arms, not through some mysterious galactic current sheet. It's not a thing that the sun experiences, so congratulations, which is not to suggest that there's not a 12,000-year catastrophe cycle. Moving on to some more solar data. The real-time solar wind is currently at 8.42 protons per cubic centimeter in terms of density. And the solar wind remains elevated here at 475 kilometers a second. There is a coronal hole wind stream on the way, so don't be surprised to see an increase in the density followed by a drop-off in the density and an increase in the velocity in the next about 24 hours. The KP index currently at 1. That's a measurement of global geomagnetism. Thanks, new viewers, for tuning in. If you weren't aware, that's what we use for earthly geomagnetism overall general measurements, the KP index. Next, looking at the geospace. Oh, look, it's the geospheric environment, which is, by the way, inside the heliospheric current sheet, unlike the sun, which really isn't inside of any sort of galactic current sheet. If you said it's inside of a galactic current tube or an interstellar chimney or an interstellar tube or whatever, I would buy it. Otherwise, you should sell it. And you should sell it for a very cheap price because it's nonsense. Anyway, there's the pressure over the past 24 hours in geospace. Next, looking at ground magnetic perturbation, since we're living through a geomagnetic excursion, we show this 4 hours of data daily, courtesy of University of Michigan. And you can see changes in the Earth B field there, both over the Canadian North Pole, less so over the Siberian North Pole, and over the South Geomagnetic Pole, which has crept off of the Antarctic continent and is someplace around here, south of Australia, thousands of miles from the South Geographic Pole. Continuing on to see a flatlined proton flux, and we don't expect any increases as we haven't seen any coronal mass ejections. Here's the 3-day chart of the X-ray flux, which is pretty flatlined as well. Just a small B-class flare which came in around 7 o'clock universal time, a couple hours before we did the daily space weather. Here's the 3-day chart of the GOES magnetometer. And you can see there some little sawtooth patterns happening. Let's see if we can get a bearing on that. We should still be in the North Pole current sheet. And here's the top view ecliptic plane field plot, which shows a real thing, the heliospheric current sheet. And you can see the Earth is solidly still in the North Pole oriented current sheet. Let's bring up the last image here. And you can see some striations there in this small region. Dense plasma, less dense plasma. Most likely the responsible thing for those striations in the GOES magnetometer. Next, we'll look at a different view here, the line of sight coronal hole plot. And you can see a North Pole coronal hole rotating in. We'll show you close-ups of that on 193 angstroms at the end of the video. And you can see the coronal hole in red there at the bottom. That's the South Pole oriented coronal hole. We should be receiving the wind again from that. We should be receiving the wind from that in about 24 hours. Within about 24 hours, possibly less. So look for an uptick, a characteristic uptick in the solar wind density without an increase in the solar wind velocity until the density comes back down, the characteristic signature of a high-speed coronal hole wind stream. Next, looking at the same view here, also including the poloidal field plots, as well as the solar magnetometer, solar magnetogram rather. And lastly, it's a view of the coronal magnetic field plot. Lots of closed potential field surface source lines there, which you can see in pink. As well as some equatorial coronal hole potential field surface source lines in purple. And you can see the polar coronal hole potential field surface source lines in black. Let's talk electrons. We don't really see that many. And once again, I hit the forecast on the head. I forecasted lower levels of electron flux than NOAA, and I was right again. There's the 1-year chart of the electron flux, courtesy Solon.info. And there you can see the forecast I did yesterday was exactly on. Once the coronal hole wind stream strikes, we're going to see an even further decrease, which will make these incorrect as well. If you don't believe me, just tune in next time, and we'll show you how right I was. Here's the 3-day chart of the electron flux, and you can see a dip there as I forecasted. Here's a visualization of the electron content forecast. This gives you an idea of where GPS errors would be located, such as over North America. We also see some anomalies over the southern Indian Ocean at nighttime and over Antarctica. And by the way, here's where the electrons are located at the Van Allen belts. This one shows you the inner and outer, and the altitudes in miles of things like the Solar Dynamics Observatory, GPS satellites, and the International Space Station, which is at a low Earth orbit. Here's another diagram. Keep in mind this one shows you altitudes in kilometers as opposed to miles. And let me just check the life of the stream here again and check our chat. Again, thanks for leaving comments. John, aka Life Force Rejuvenation. What's in your plasma? And for you new viewers, the GOES-16 is making its measurements, or attempting to, at the F ionosphere layer. Let's take a look at the ionosphere. Here is the F layer of the ionosphere, shown in megahertz, which is a frequency. We're looking at the vibration of the ions here. And you get the highest vibration typically under where the sun is located. We see some anomalies here in the southern hemisphere once again. Nothing too extreme. Pretty significant though. And we'll bring up the last image here. There's the latest image, I think, at 9:30. Looking pretty normal there, a little charged up on the nighttime side of the planet. Next we'll look at volcanoes. Are you charged up about volcanoes? Well, Kluchevskoye and Shiveluch are both erupting on the Kamchatka Peninsula, producing a 20,000 and a 23,000 foot ash plume, respectively. Sakurajima also erupting, 7,000 foot ash plume there. Suwanosejima, 4,000 foot ash plume over that caldera. Sinabung, an eruption reported by Ground Observer. And Sinabung is, I believe, the deadliest volcano of the past few years. It caused a tsunami and about 300 deaths, I believe. Popocatépetl exploding. Flight level 190, it's a 19,000 foot ash plume. Fuego, Sangay, and Revenador are all exploding. 15,000, 20,000, and 16,000 foot ash plumes there. And we're unable to detect whether or not Sabancaya in Peru is erupting. Please do not attempt to do a back handspring over the caldera. One of the more interesting quakes of the past 24 was this Cascadia Quake here off of the coast of Oregon. It's a 5.7 magnitude, and that's the location of that significant quake. Let's go back to the list and look at all of the quakes of the past 24. I'll just scroll up the list here. There's a deep quake under the Philippines, a 4.5 magnitude at 166 kilometers. A deep quake strikes Tajikistan, only a 4.3, but 99 kilometers depth there. Lots of clickbait on Facebook, too. If you'd like to see a lot of clickbait, go to Facebook. Deep quake under Japan, a 4.8 magnitude at over 430 kilometers depth. And I like the smooth scrolling. What say you? Let me just get back to the stream live here, and we are doing just fine. Again, we are streaming live. It's twitch.tv/smAshomash. Thanks to our YouTube viewers who view the premiere. We enjoy viewing the premiere with our YouTube viewers, as I'm not only smAshomash, but I'm also a client. Yes, I watch the videos. And if you're producing content that you don't watch yourselves, it might be crap. To quote Norm Macdonald, crap. Now we're looking at surface winds over the U.S. to see an upward, northerly winds there over places like Texas. And Texas, you've got a 10-inch snow forecast in that area where you see those winds. Yeah, southwestern Texas. You're very likely to get snow by the time the year of accountability 2021 begins. So let's just go to the jet stream here. And there's what's going on the jet stream. It's the jet streams of the Western world. Let me rotate that a little bit so our European viewers can see. And thanks for tuning in from whatever continent on which you are located. Quite extreme meridional jet stream flow in the entire northern hemisphere there. Doubled up and tripled up jet streams over the U.S. and some backward flows over South America. Here are the jets of the eastern world. A little more coherent over there, but doubled up over the southern hemisphere as well. Next, looking at our GOES lightning mapper. As that GOES-16 is a highly skilled spacecraft. And you can see some stagnant lightning there to the east of Bermuda, just hanging out. The Sargasso Sea, one of the weirdest places in the world, folks. The only sea on Earth which is not surrounded by land. And it's full of eels and kelp. Yes. Sargasso weed, I think it's called. Check it out, Australia's seeing some lightning. We're on lightningmaps.org now. And yes, you can use it to forecast thunder and freak out your foes and convince them that you're Thor. Oh my God. Evans Head Air Weapons Range, there's thunder rolling in. I break out lightningmaps.org when I hear thunder. Hey, Del Nietzsche, there's thunder rolling in. Let's get into more meteorology stuff here. We've got some heavy snow over especially Nebraska. As well as possibly over my head. I'll have to go out and look before we premiere the video on YouTube. And I just wanted to note that I forecasted this as we saw 3 winters in a row with 2 standard deviations above normal snowfall. That's, when I say normal, I mean the 30-year average. And now the Northern Hemisphere is back on the average. I forecasted less snow, as it's pretty anomalous to see 3 years with 2 standard deviations above normal snowfall. Again, the Northern Hemisphere, as you can see, is back in the normal 30-year average range for snowfall. So there's the data. And for all of you who don't like it, too bad. And for all of you who don't know how to forecast weather, stop forecasting weather. Here's where we expect things to be when the ball drops in London at 0 hour. The first moment, the first second of the year of accountability. As technically midnight is actually still the year 2020, year of clarity. Is it becoming clear how much snow is going to fall in southwestern Texas? Yeah, the GFS forecast is calling for 10 inches. As well as 13 inches for southwestern Iowa. And since it's the 29th, that's not so outlandish of a forecast. Check it out, windy.com agrees. Here's the Euro forecast for the same moment. So we showed you the GFS, here's the Euro forecast, and they're calling for over 10 inches of snow there. So the forecasts actually agree, and without looking too in-depth into it, I would tend to agree also. Here at the Smash News Network, I do understand the physics. And I don't do a lot of weather forecasts. Maybe I'll do one on New Year's Day, who knows? And maybe if we ever go full-time by getting enough views and funding to do so, I'll do lots more videos about meteorology. Speaking of meteorology, here's what's going on in the cloud layer. Check out this long string of low clouds off the East Coast. It's not a chemtrail. It's not a contrail. It's low clouds. And here's what's going on in the water vapor map. And it looks like it's going to dry out where I'm located pretty soon, as we see dry massive air over northern Pennsylvania already. And we're going to zoom in on the border of Missouri and Nebraska to show all of you blizzard people what may happen next. If the Doppler radar is failing you, check out the water vapor map. I like to use the NASA GOES interactive weather satellite. And there's the water vapor situation. It looks like that system is taking its good old time, as there's not a lot of dry massive air to push it through. And we'll show you the zoomed out view once again. And again, there's the cloud layer. And it's time for bonus features. A regular thing here at the Smash News Network. We're going to show you the colorized magnetogram, the intensitygram, and some close-up views of the North Pole-oriented coronal hole system and the North Solar Polar region. So firstly, here's sunspot 2794, which is under my pointer, and sunspot 2795, which has degraded a bit, although there still is significant magnetic field associated with both the leading and trailing umbrae. It's a beta-class sunspot, as those umbrae are opposite polarity. And there's that active rising region, again, still not a sunspot. There's a close-up and high res of sunspot 2794, 2795, as it degrades. And the likelihood of big solar flares has dropped a bit. With that, no umbrae associated with that rising active region. And here are the 193 angstroms views of the local yellow dwarf, otherwise known as the Sun. And you can see that coronal hole in the North Pole region, as well as the one from which we are about to receive a high-speed wind stream, this one down here. I don't keep track of coronal hole numbers, although they are numbered, and you can keep track of those if you like at solon.info. Here's a close-up of the active rising region in 193 angstroms. We don't always show it, and I don't always vanish, but I have now. And a good view of the Earth scale there as well. Here is the north region, and we zoomed way in there to get a real close-up view of that new, most significant coronal hole there. Great view of that, as well as the North Solar Polar region. And that's all she wrote, folks. Thanks for tuning in. It's about time to close this thing out. I've been your host, Dan, aka smAsho. Don't forget to press like and subscribe. Don't forget to share the content on your social media. Tell your foes, friends, science pros, science noobs. And this is where the video ends. May that solar wind be at your back.